Hey everyone, welcome back to my channel. Today we'll be looking at Circle Theorem and we'll be also working through 2 exam questions. Before we go ahead, hit the subscribe button if you're new to this channel, and if you've been here before, then welcome back. I hope this tutorial helps you to better understand circle theorems, so stay tuned for more. Before we go ahead, we first need to know the parts of a circle. On our left, we have a circle highlighted in red. A radius is described as a point that goes from the center of a circle to one point of the circle. A diameter is twice the length of the radius, and this is a line that is drawn from one end of the circle to the next, but it passes through the center. Highlighted in white, we have a tangent that touches the circle. And where a tangent and a radius connects, it forms a 90-degree angle. We then have a chord highlighted in blue, and this is just a line that touches from one point of the circle to the next point. A diameter is a chord, and it is the longest chord, but a chord is not a diameter. Where the chord and the arc meets, that is known as a segment. On our circle on our right, we have a minor sector and a major sector. And this is the point where 2 radius meets and an arc connects. So the smaller one is obviously the minor sector and the larger is the major sector. Facts that you should know about a circle are, firstly, the angle between a radius and a tangent is 90 degrees. Fact 2. A triangle which has one vertex at the center of a circle and 2 vertices on the circumference is an isosceles triangle. This means that our angles at the circumference are equal to each other. Fact 3. Tangents that meet at a point outside of a circle are the same length. It is now safe to say that we know the parts of a circle and facts about a circle. We now need to know our circle theorems, as this is very important to answer a circle theorem question correctly in an exam. We have 6 circle theorems. The first one states the perpendicular from the chord to the center of the circle bisects the chord. Number 2. Opposite angles of a cyclic quadrilateral add up to 180 degrees. A cyclic quadrilateral is a quadrilateral that all of its sides are inside of the circle. Therefore, if one of our points were outside of the circle, this would not be a cyclic quadrilateral and the opposite angles would not add up to 180 degrees. Number 3. The angle in a semicenter is 90 degrees. As we can see, we have a diameter and then we have 2 lines that are connected. Those 2 lines, wherever they meet inside of that semicircle, it will always equal to 90 degrees. Number 4. Angles in the same segment are equal. As we can see, our angle on our left, x, is equal to our angle on our right, x. That is because they are in the same segment. Number 5. The angle at the center of the circle is twice the angle on the circumference. As we can see, the angle at the circumference is x, and the angle at the center is 2x, which is twice that of x. Number 6. The angle between a tangent and a chord is equal to the angle in the alternate segment. This is called the alternate segment theorem. As we can see, we have a tangent connected to a circle, and we have 2 chords that's connected to that tangent. The angle between the chord on the left and the tangent is x. And as you can see, the alternate segment angle is also x. Therefore, if our angle was on the right of that tangent and the chord, then therefore our alternate angle would have been on the left side of that triangle. We will now move on to our first exam question. A, B, C, D are points in a circle. PA is a tangent to the circle. Angle PAD is equal to 39 degrees. Angle BCD is equal to 103 degrees. Calculate the size of angle ADB, which is that angle right there. So the first thing we do is assess our circle. We know we have a cyclic quadrilateral and we have a triangle in our circle. We also have a tangent. We know in a cyclic quadrilateral, opposite angles are equal to 180 degrees. And that's according to theory 2. So 180 degrees minus 103 should equal to our angle at A, which is 77 degrees. So we're going to just write that in. So angle A is equal to 77 degrees. We found one angle. We're now looking again, and we know according to theory 6, the alternate segment theorem, the angle at A between the chord and the tangent must equal to the angle at B, which is 39 degrees. Theorem 6, sorry. Looking again, we know that we have a triangle right there. We know two of the angles. We need to find one more. We know the interior angles of a triangle is equal to 180. So 180 minus the two other interior angles, which is 77 plus 39 degrees. That will equal to our angle which we are trying to find, which is ADB. Now we need to just multiply that bracket, or negative to our bracket. Rewriting that, we'll have 180 degrees minus 77 minus 39. And that will equal to 64 degrees, which is our answer. So angle ADB is equal to 64 degrees. Number 2. The diagram below, not drawn to scale, shows a circle center O. The line DCE is a tangent to the circle. Angle ACE is equal to 48 degrees. And angle OCB is equal to 26 degrees. We first ask to calculate angle ABC, which is this angle here. From theorem 6, which is the alternate segment theorem, we know that whatever our angle is here, our angle would be the same as B at B. So our angle there at our chord and tangent is equal to 48 degrees. Therefore, our angle ABC would equal to 48 degrees as well. Next part of our question asks, what is angle AOC? Which is AOC here. Good. We know from theorem 5, we know that the angle at the center of a circle here is twice the angle at the circumference here. We know the angle at the circumference is 48. So 48 times 2 would equal to 96 degrees. And that is our angle at O. Next part asks us to find angle BCD, which is our angle here, BCD here. We know, from what we know about a circle, we can see this is a 90 degrees here. Oops, that's 90 degrees. And from what we can see, we have a 26 degree in there. So if we subtract 90 and we subtract our 26 degree, then we'll get our angle. So 90 minus 26 degree would equal to 64 degrees. And that is our angle BCD. Next part of our question asks us to find what is angle BAC. Angle BAC, which is here. From our alternate segment theorem, we know whatever our angle is here, that would be our angle at BAC. BAC would equal to our angle there, which is 64 degrees. Good, we're almost there. Next part of our question asks us to find angle OAC. Angle OAC, which is this little angle right here. Right there. In order to find that angle, we can first find our opposite angle here. We can first find this angle. Let's just take a step back and look at the angle on this straight line. So we have our tangent here, And with our tangent, we have our radius. With our radius, we have an angle 26 degrees. 26 degrees. And we have 64 degrees here. 64. In total, this is equal to 90 degrees. Yeah? And we have a 48 degrees angle here. 48. We know that the angle on a straight line is equal to 180 degrees. So if we're to take 90 degrees plus 48 degrees and subtract all of that from 180 degrees, our angle here would equal to 42 degrees. And from what we know about an isosceles triangle, let's just do a quick sketch with that. Here, yeah, isosceles triangle, we know that this length and this length is the same, which means our angle here and our angle here are also the same. So if we have 42 degrees here, then therefore our angle here would be 42 degrees as well. Therefore, our angle at OAC is equal to 42 degrees. I hope you kind of understand that. It's a bit tricky, but once you take out your information, it's easy to find the answer, okay? Now the last angle that we need to find is angle, let's use another color, angle OAB. Angle OAB is, let's find angle OAB, which is going to be this little angle right here. We already know our total angle here. Our total angle here is 64 degrees, and our angle here, is 42 degrees. So 64 minus 42 would give us our answer, which is 22 degrees. And that is how we solve our question. So step by step, we take out the information we need, we use our theorems, use our facts that we know about the circle, our parts, etc. And we can easily find our answer to our question. Okay? And that brings us to the end of today's lesson. Please feel free to leave a comment of any other topics that you would want me to cover. And don't forget to like, share, and subscribe. I really do hope today's lesson gave you some extra knowledge to tackle any circle theorem question. For now, thank you so much, and until next time, bye-bye.